on watching me prove everything. What does this even mean? Okay, let's walk through just the entire steps of using ZK proofs to prove everything. I've been working in the Metis ecosystem for over 3 years. I do mostly governance now, but I did work as the integrations lead, so I know a lot about the ecosystem, the different projects, how everything can be built unified and together. I developed 3 articles related to different types of bridging techniques. So from NFT bridging to L2 bridging to, well, we're going to find out what the 3rd version of that is. I also built smart contract-based applications using my own essentially model of distributing rewards for influencers based on specific, let's say, requirements. So I know basically the practical, the theoretical, as well as the BD aspects. So what a way to unify the entire ecosystem using bridgeless bridging. So what we have here is a scenario. Alice wants to transfer 100 USDT to Bob from Ethereum to Avalanche. Alice wants her bridge to be trustless, extensible, and liquidity optimized. ZK proofs have been built for 2 main use cases, privacy and verifiable computation. We're using ZKM for verifiable computation, but it can be used potentially for privacy as well. Right now in this example, we're focused on the verifiable computation. How a ZK rollup works. Step 1, take a batch of transactions. Step 2, generate a proof that you've executed this batch correctly. Step 3, you send the proof to the specific layer 1 for finalization. That's how you ensure the security of that the actual transactions happened. The first bridge I want to talk about, the ZK-based bridge that I want to talk about is ZK Bridge. It uses layer 0 for liquidity and message passing. Remember our 3 things that we want. We want trustless, we want extensible, and we want liquidity optimized. Well, if we take a look under the hood, layer 0 is not trustless. I have to trust them a lot. I have to trust them for different things. They have many different types of trust assumptions built into the protocol. So even if I use ZK proofs, I am essentially trusting that layer 0 provides me my assets that I've transferred. I have to trust them. The next one is ZK Link. We're using native liquidity for we're using native ZK proof verification, but there are liquidity assumptions. It's not liquidity optimized. What do I mean by liquidity optimized? It means that if I deposit my 100 USDT, I will get 100 USDT on the other chain guaranteed. So an implementation using ZK Link, ZK Jump, essentially says that a quote is made, and essentially whoever fulfills this quote would then have their assets bridged. If no one fulfills the quote, if I want to transfer $100 million and there's no one to offer me that counterparty to transfer that $100 million, I can't transfer it. There's no agreement. So how can we make this better? How can we use the liquidity of one chain and use it in a completely different chain, in a completely different ecosystem, unrelated to each other? Well, we need a network of usable, pooled resources and a trustless, extensible system that combines them all together. We have the entangled rollup infrastructure. Now, it's a bit hard to see, and it's a bit complex. But I have an implementation utilizing this initial entangled rollup structure and essentially through a universal layer 2. You can read about how this all works. By the way, we have a white paper out. But I want to explain it in simple, understandable terms. But it's using this version of infrastructure, let's say, to do it. So the entangled rollup can actually implement and adopt other L2s, optimistic rollups, ZK rollups, and hybrid rollups as well. Now, hybrid rollups is the combination between optimistic and ZK. But essentially, I can adopt any other layer 2 that's already implemented. Arbitrum, Optimism, Metis. We have different types of layer 2s that already exist in the ecosystem, and they can all be included within this type of structure. So what am I proposing? What is this bridgeless bridging? Well, it's combining native verification with shared liquidity. Essentially, any deposit that would go into a layer 2 would increase the liquidity for the entire ecosystem that adopts this universal L2 structure. So for example, 100 USDT deposited on the Ethereum L2, and 100 USDT deposited on the Avalanche L2 would have an increase of 200 total USDT, total amount of usable liquidity that I can then transfer from any other layer 2 connected within this network. Here is how it works. I have a layer 1, I deposit 100 USDT. I then have my Ethereum universally integrated L2. Again, this could be Optimism, Arbitrum, Metis, any of these L2s. I would then have the assets minted to my address. I would burn that exact amount of USDT. I would then do a public burn address, and potentially can be private, and I'll go into that a little bit more. But we burn it to a publicly known burn address. We then generate a proof based on that burn. We're not generating it off of the L2 data, we're generating it off of the L1 data. This ensures that this transaction is secured by native L1. Secured and finalized. So that means that nobody can say that they burnt something, but in fact, not have burnt it. So this liquidity, this 100 USDT, is provably removed from the ecosystem. But now I can burn it. I can generate a proof of that burn. And I have a receipt that basically says that I can redeem this 100 USDT on any other connected universal L2. So this means I can take this and I can send it to the Avalanche L2. And it's using the native mint function on that L2. So what this means is that I am burning native liquidity on the L2, on Ethereum, and I'm minting a corresponding amount of native liquidity on this other L2. This L2 is built on top of Avalanche. In this case, Avalanche would resolve this transaction and finalize it on its own L1. I do not require an external consensus mechanism. I do not require external validators to verify that this in fact occurred. I am using ZK proofs as the means of communication in order to facilitate this transfer. What does this mean overall? And what do I mean by watch me prove everything? Within ZKM's ZKVM, we are able to prove general computation that occurs. What does this mean? Well, I can run VMs inside of my VM, inside of the ZKM's VM. I can prove that some level of computation has occurred on each and every single L1, even if they're incompatible with one another. As long as they have some type of way to have a smart contract function or some type of way to allow me to verify a proof on their chain, I can integrate. So this means that I can verify Ethereum transactions, EVM transactions, MVM, MoveVM transactions, Solana VM transactions, Near VM, as well as Algorand VM. Like, I can introduce this to any other incompatible L1 and still have the same trust assumptions of each and every single L1. Each L1 secures its corresponding L2, which is then using proofs to pass messages across all of these layer 2s. This also allows me to mint any amount of liquidity, native liquidity, on each and every single one of these L2s. What this means is that if I burn $100 million on the universal L2 on Ethereum, I can bridge this to any other universal L2 connected within this ecosystem using the native mint function on these corresponding L2s. This means that I'm using native liquidity within these entire ecosystems. I do not need to go and pitch to VCs and say, hey, store your $100 million on this chain here, and I'll promise I'll facilitate some transfers. No, I'm essentially utilizing the liquidity that's provably burned, and I can mint it across entirely different, incompatible ecosystems, essentially being able to prove anything. So what's the pros of this type of model? One, it does not depend on any external third-party validators to facilitate this. I am relying on the proof generation system, the proofs that are generated for enacting the mint. So the finality of this type of interaction, I essentially utilize the native L1 consensus mechanic for all of these individual L1s. I'm not using an external consensus mechanic. I'm not using an external set of validators, like potentially Cosmos or Polkadot. The other big part is that it can work between other incompatible ecosystems. It doesn't just work with EVM. It doesn't just work with Tendermint. It doesn't just work with this one thing. It can work with all EVM and non-EVM chains, essentially securing it through these verified ZK proofs. The next point, and the most important point, I think, is that it's liquidity optimized. The one thing that I have to convince people is, well, to convince anyone to adopt a solution is there enough liquidity? Do I have enough liquidity to facilitate this? Do I have enough demand? Do I have enough people? And in DeFi, liquidity is the most important thing that's talked about across everywhere. How can I get enough people to use this product? That's why a lot of things are being built on Ethereum, because there's a lot of liquidity there. There's now migrations to other layer 2 ecosystems. But again, liquidity, liquidity, liquidity. This uses the native L2 mint function. This gives me native, or in this case, proxied USDT, but it's used as the official USDT of the network. So this means that this USDT, I don't have to swap it for another USDT. I don't have to, transact or maneuver it. I essentially use this as native assets on the L2. This also, we see a lot of funds locked in L2s currently. There's $12 billion locked in Arbitrum. There's a few multi-billion dollars locked in other L2s as well, like Metis and Optimism. So we have billions of dollars of locked liquidity in these ecosystems, essentially just stuck on one ecosystem. We can have let's say the liquidity locked on one ecosystem, it's still locked on Ethereum, it can be used anywhere across any blockchain ecosystem, again, utilizing the native mint function. There are two major cons to this type of model. The biggest one is that access to the native mint function. In order to have this solution be adopted, we have to get everything, in order for the native mint function to be used, essentially the chain has to give the privileges of that to this proof system, to this proof generation system. What this means is that we're using the ZK proofs as a means to mint it. The only way to traditionally mint the assets is by a deposit to L1. The other way in this model is to mint it using a verified proof that you've burned the asset on some other chain. As a result of this, in order to convince any other chain to adopt this, we need the mint function of that chain. But every single time any chain adopts this, it increases the entire liquidity of the entire network. So we're seeing a lot of L2s pop up. A lot of implementations pop up, some privacy-focused L2s, some compatibility-based L2s. What we can see is that they all have that same problem. They need liquidity. They need to be onboarded. And how else are you going to transfer hundreds of millions of dollars from one to the other? So it's beneficial for the user standpoint. It's beneficial for new starters to come in to use the already existing liquidity in the entire ecosystem. The other downside is that there might be dry spots. Remember that scenario where I deposit USDT on ETH. If I want to withdraw this on Avalanche, I must have a corresponding amount of USDT on Avalanche. If I don't, let's say I bridge that 100 million to Avalanche, but Avalanche only has 1 million. Well, I can't utilize the entire, let's say all of my assets on that L2 to L1. I would have to then bridge to another ecosystem that contains that liquidity. But in this case, that is a very minimal issue, since you will always be guaranteed to have liquidity somewhere. It might not be on the native chain that you use to deposit. Instead, it might be on another L1, which then you'd have to bridge to, but then at that point, it's still the equivalent, let's say, value. That USDT on Avalanche is equivalent to the USDT on Ethereum. We also have a potential extension to this, and this is actually the EIP that inspired this entire aspect of essentially using proofs to verify that you've taken the asset out of circulation. This EIP essentially says that we can burn ETH on Ethereum and then privately mint it to another address. In this case, we're using this similar model to do it across different L2 ecosystems. Instead of burning directly on ETH or privately burning on ETH, we are now burning on the L2, which then resolves to the L1. We can also extend this, and as I said, to the privacy aspects. So we could technically implement this potential EIP as well for this cross-chain native bridgeless bridging mechanic. So this is what we're doing here at ZKM, is creating the proof system for the interoperability of incompatible blockchain ecosystems. Since we are a general purpose ZK VM, we are able to prove computations across different types of other VMs. And as a result, the bridgeless bridging, the universal L2 model, can be adopted within this system using this type of ZK proofs, generalizable and efficient. Thank you.
All right, thank you very much, Pavel. That was